Okay, question number 3. We have millions of dollars against months. Which the variable T1 represents January, T2 represents February, and so on. Okay. Cubic polynomial, so I've defined that cubic polynomial over here. Local minimum at 2, so that's a local minimum, and that's a local maximum. And we're suggesting we have a curve in between there. Okay, so to solve for A, B, C, and D. Okay, so I know that P of 2 equals 2500, P of 11 equals 4400, P dash of 2 equals 0, and P dash of 11 equals 0, and solve for A, B, C, D on the calculator. Okay, so if I bring up Math 1, simultaneous equations, touch it 3 times, I'll get 4 lines. I'm interested in my f of x, so I'll copy that and paste, 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 paste. Now, when you do your derivatives, make sure you don't put the x value in first, because if you put the x value in first, you will end up with 0 and the derivative, or a number, and the derivative of the number is 0. So you make it equal 0, then afterwards make x equal 2, and we'll do the same with this last one. We'll take the derivative of f of x and then make that answer equal 0, given x equals 11. Copy, get rid of all of that. Given paste. But up here I can do f of 2 equals 2500 and f of 11 equals 4400, and solve for A, B, C, and D. And we're looking for 2 decimal places. So A equals negative 5.2, 2 is after the 1, so 2, 1. B is equal to 101.6, so it happens after the 4. It's a 6, so 5. C is equal to negative 344.04, and D is equal 2823.18. Okay. Let Q be from that to that. So we're moving to the right H and up K. The graph Q has a local maximum at this. Okay, so Q at the moment has a local maximum at 114400 from the previous page, and we want to make that equal 234750. So I wish to go across from 11 to 2312, and I wish to go up 4400 to 4, so 350. So the K is positive 350, and the H to the right is also positive 12. Okay, part B. Another rule is used So 3,000, yep. Complete graph. Okay, so I might graph that and then get some points. So 3,000, I'll type that in. Okay, so I've typed that in. I'll change my window to match the window here. So we're going from 0 to, I need to go to 36, so I'll go to 37. 0, and that goes up to 6,000. So I'm just following the numbers that are on the graph. Pick that up and drag and drop. So this one here is this one here. So I need to draw that. So how about we do analysis? G-solve maximums. So that should be at 24.48 it is. So I have another maximum at 30 and 3601. So 30 and 36. That's 35, so around about there. Jump across to my next maximum, which is 36. So it's just beyond where I wish to be. So 36 and 5182. So 36 and 5182. So it's around about there on 36. So I might do analysis G-solve, graph down here. Analysis G-solve minimums. So that is 27.7, so nearly 28, and 3281. Nearly 28, 3281 is around about there. The next minimum across is 32 and 3409. 3409, nearly 35. 32, sorry, so we're down here. Okay, so I reckon that I can draw this. And that's going to be 36 and I'll do analysis G-solve Y-calc on 36. And it is 5180. Complete the endpoint, done that with its coordinates, and that's what my graph's going to look like. Okay. The function f predicts that every 12 months the monthly sales increase by n millions of dollars. Find the value of n. So that's a constant. This will go up and down, +1, -1. That will go up and down, +1, -1. Here is the thing that's going to increase definitely each year by an extra 30. As t goes up by 1, we get another 30. As t goes up by 1, we get another 30. So the value of n is 30. Find the derivative. Okay, so if I come here, analysis, calculation derivative of the last answer, okay. And maybe if I simplify that answer, this is my 30. So I've got f dash of t equals 30 minus 400 on 3 sine of pi t on 3. And I'll put a pi in there, minus 350 pi on 3 sine of t pi on 6. Hence find the maximum instantaneous rate of change. That is when the gradient is the steepest. So if I graph the derivative, there's my derivative, 1 decimal place. I'm looking for analysis, G-solve maximum on my derivatives, and that's going to be 725. That's also 725. So 725.39 at t equals 22.24 and 10.24. Okay, so find the max. So it's $725 and the values of t when it happens when t equals 10.2, 22.2, and all the way up to 36. So there must be a third one over there. So let's jump across. And that's 34.2. So there's my answers for that. And that's question number 3.